Hello everyone, Jai Hind and welcome to the platform of StudyIQ IAS in English. My name is Bhanwar Singh, so I'm XAD 115th course and qualified civil services in 2012. And I welcome you on the platform of StudyIQ IAS. Now over here in this video, we'll be talking about the geomagnetic storm and as well as the space weather. Now this complete video or the session is all about because of the recent sunspot activity at AR 4455, which has unleashed the triple solar flare towards the Earth or towards the globe, and over here Earth had been directed towards the cannibal CME or the coronal mass ejection as well. Now this is where we are talking about G3 strong geomagnetic storm alert, which had been alerted or issued by NOAA, and that is why this session is very important to understand what actually geomagnetic storms are and what is AR 4455 and even what is meant by cannibal CME or the coronal mass ejection as well. Now when it comes to geomagnetic storm, please remember that it is basically the disturbance that is caused because of the solar flares or the coronal mass ejection, that are the bouts of the charged particles which escape the solar surface. Now this temporary disturbance is of the Earth's magnetosphere, which is caused by the severe solar wind, and ultimately the shock wave or the coronal mass ejection, they interact with the Earth's magnetic field, and that is what results into the geomagnetic storms. Now we have the magnetosphere. The magnetosphere is basically a protective magnetic shield that surrounds the Earth. There is also solar wind. The solar wind is basically consists of the charged particles or the stream of the charged particles which are emitted from the sun's surface. There is plasma as well, which is hot ionized soup of the electrons and the protons, which is emitted from the coronal layer or the coronal layer of the sun. And there is magnetic reconnection, where we have the gateway where the energy gets transferred into the atmosphere, and this could be very, very harmful as well. Now when it comes to the triple solar blast, so there were three of the blasts that were there, or three of the events which were recorded. Now AR 4455 is actually the magnetic complex and unstable region that is located on the sun midsection. Now ultimately from here there were the three bouts of the solar flare that were ejected. Now let me tell you that what sunspots are previously. Now when it comes to sunspots, basically these are the regions where the temperature at the surface of the sun is lower, and that is why they look dark when you are seeing the surface of the sun. Now there is a complete sunspot cycle that is for the 11 years, during which the sunspots they gain maxima and then they wane out. That is, we have the minimum cycle that is there. Now these three of the different solar flares which have been released from AR 4455, that is the sunspot located on the sun surface. The first one was M93 flare, and that has resulted into R2 blackout over the East Asia and Australia. There was M7.7 flare, that is again the R2 blackout affecting India, Europe and Africa as well. And there was X 1.0 flare, that is the R3 strong radio blackout, the flare that was released from AR 4455. Now over here, when it comes to the X1.0 flare, so remember over here what has happened is that M7.7 was ejected as a slow and massive plasma that was moving towards the Earth. Then there is X 1.0 that was ejected. Now X 1.0 had more speed or velocity, and ultimately what happened was the faster CME, that is X.0, it overtook and ultimately absorbed the M7.7, and it has formed a single highly potent unified monster, that is the cannibal CME, or you can say that is the cannibal coronal mass ejection, where we have the merged cloud that is moving towards the Earth. Now there is an impact change. When it comes to the impact, you can see that the M9.3, there was moderate impact for the radio blackouts over the East Asia and the Australia. For the M7.7, there were R2 blackouts in India, Europe as well as in Africa. And X 1.0, this was the strongest flare class, and there was the high frequency radio blackout. And ultimately the cannibal CME, it is Earth directed G3 level of the geomagnetic storm that had been triggered because of the cannibal CME or coronal mass ejection. Now you can compare this with an umbrella. Now what happens is that we have sun, which is the mischievous neighbor that we have, and when it comes to the Earth, and along with this it has high pressure water hose, that is through which high pressured water there is the solar winds as well as the coronal mass ejection that comes out. Now what happens is that India has, I'm saying India, the Earth has the magnetosphere. Now this magnetosphere is basically the sturdy umbrella that that the Earth has. All right. Then comes the normal solar wind. Now when the normal solar wind is there, so the Earth is not impacted that much. All right, it is like light drizzle, and the umbrella, it handles it effortlessly, and there is not much of the effort that the magnetosphere has to make. Then when it comes to the CME or the coronal mass ejection, it is just like that there is a rapid blast of the water, and thereby the umbrella bends and it shakes violently. And then comes the leakage, where the water, it comes down, or the water or the charges, they get inside the Earth's atmosphere. And ultimately there are the electric currents that enters the power grids and the pipelines, and that is why this is very, very dangerous as well. Now you can see that it can result into the grid failures also. Now what happens is that if there is solar flare, so it is light, and ultimately this is just about radiation, and it is of the speed of the light. All right, it travels with the speed of light and reaches the Earth in 8.3 minutes. So it ionizes the upper atmosphere, and immediately there are the high frequency radio blackouts that you can see on the sunlit areas or the sunlit side. Then we have the solar proton events, which are high energy particles which are released from the surface of the sun, and they take nearly about 15 minutes to a few hours to reach the Earth's magnetosphere. And here there is the radiation hazard that is there for the astronauts, and even the high altitude flights, they can get damaged. The communication system can get damaged, and it also damages the satellite electronics that are there. And especially when it comes to the satellites which are there in the GSAT orbit, or they are in the geosynchronous orbit. So what happens to these satellites? They are very high, all right, they are nearly about 36,000 kilometers above the surface of the Earth, and that is why these satellites, basically they are communication satellites, and they get damaged by the solar proton event. And when we have the CME arrival or the plasma cloud or the coronal mass ejection, so they reach Earth from 1 to 2-3 days. All right, so that is the type, and ultimately it will compress the magnetic field, triggering the geomagnetic storms, auroras, and even the power grid failures that can happen because of the powerful impact of the coronal mass ejection. Now the Earth is basically defending itself. We have the magnetosphere, which is very important, and over here what happens is that there is dipole field which is generated because of the Earth's interior. We have the iron core. When it comes to the core, we have the Nife or nickel and the iron that is found in the Earth's interior. The outer core is basically in liquid form, and the inner core is in the solid form. And because of the rotation of the Earth, what happens is that there is differential rotational speed between the outer core and the inner core, and that creates the dynamo effect. And that dynamo effect or geodynamo, it results into the Earth's dipole field or the Earth's magnetosphere. Now over here what happens is there is a boundary where the solar wind first collides the Earth's field. Now over here, when the solar wind, it collides with the Earth's field, there is the slowdown, or it slows down abruptly, and that is what is called as the bow shock. Then we have magnetotail, which is staged night side field pointing away from the sun, and it is in the shape of teardrop. And also there is the polar cusp and the auroras, where we have the weak leakage points, and ultimately the charged particles, they enter into the the magnetic field, and they are green and the red auroras that you will see, where we have the charged particles, they actually you can say they interact with the Earth's magnetosphere. So over here, this Earth's magnetosphere is the defending shield that the Earth has, but at the same time, when it comes to the G3 to G5 of the geomagnetic storms that are there, so that results into the slippage of the auroras, and they slip to the mid latitudes, where you can see the auroras even in India as well. So they were seen in the India in Ladakh, and that is because of the geomagnetic storms that were there. Now, like I said in the initial, that there is the solar cycle, and the solar cycle is of the 11-year, where the sun's magnetic poles, they flip on the regular cycle, swinging between the solar minimum, that is quiet, where we do not have much of the sunspots which are there on the sun, and also solar maximum, where we have frequent flares and high turbulence. We have lots of solar storms during the high period or maxima period. Now over here you can see that this period is 2024 to 26, and here the solar cycle of 25 years is peaking, where we have seen the much higher than the initially predicted levels of the solar flares, and AR4455 is the direct product of this particular peak of the solar maxima. So solar cycle is 25, it has peaked far above the initial scientific predictions, explaining the surge in the solar storms that we are seeing on the surface of the earth right now. Now when it comes to the threat, it is not just about the auroras, but the threat is multifold, where we can have the GPS and the GNS signals, they may degrade. I told you that the communication satellites, they will be hit first because of the solar storms and the geomagnetic storms which will be there. So there will be the meter level positioning errors that will be there for the GPS and GNS signal. There will be induced currents in the transoceanic fiber optic cables as well that will damage the communication lines. Then in the economy, there would be satellite damage, and ultimately there are the millions that are used, or millions of rupee or the dollars which are used for construction of the satellite. So this would be our economic loss as well. And the burnt transformers also. If the power grid will be impacted, so there will be lots of transformers that will get burned, and ultimately they will lead months to replace, and there will be grid-wide cascades that will be there. Alright, there will be the social and the health implication as well, because the radiation exposure will be there on the polar commercial flight routes, and there the passengers, they may get impacted, and there is no direct ground level threat right now. Alright, because the atmosphere, it protects us from the from the dangers or from the solar wind as well as from the coronal mass ejection. But it is the people who will be there on the polar commercial flight routes, they may be exposed to the radiation. There is also the disruption to the migratory birds and the marine mammals, and also they may have the internal magnetic compass that can be confused by the fluctuating field as well. So this is the threat that is there because of the solar maxima, or because of the geomagnetic storms that have frequented the earth right now. Now when it comes to India, so we have the growing space assets. We have more than 50 of the operational satellites, which are basically communication satellites or the NAVIC or the earth observation, and that is, we have billions of dollars which are at the risk right now. Also, we have one unified national grid when it comes to the power grid, and ultimately any surge in one region, it will cascade to the nation-wide. Also, there is NAVIC dependency, which is vital for the defense, aviation, and for disaster management as well. And the ionospheric disturbances, it will directly affect the accuracy of the NAVIC system. There is also EIA, or the equatorial ionospheric anomaly, where we are near the magnetic equator. Alright, and ultimately the ionosphere, it boils during the solar events, and therefore there will be severe GPS scintillation or the signal flickering into the region. Alright, so we have the the magnetic pole, the equator, it passes through the through India. Alright, and the region is Tumba, where we had the first of the equatorial launch station for the rockets as well that was located, that is TERL. So therefore there will be the severe GPS scintillation that India may see because of the geomagnetic storms. So ultimately when it comes to the equatorial location, so this is protection from the polar compression, but at the same time there is the EIA, or equatorial ionospheric anomaly as well, or vulnerability, that will impact the NAVIC as well as the aircraft precision landing also. Now at the same time when it comes to India, so India was earlier dependent upon the other nations, or we were dependent upon US, or we were dependent upon European nations for the data. But now we have Aditya L1 mission. Now it is orbiting at Lagrangian point 1 or L1, and it is nearly about 1.5 million kilometers from the earth, and it is at the place where it has the unobstructed view of the sun 24/7. Now there are various payloads that is there on the Aditya L1. There is VELC that studies the solar corona as well as coronal mass ejection. There is also SUIT that images the solar photosphere and chromosphere in UV, and then there is SPEX and PAPA that analyzes the solar wind particles, protons and heavier ions. And also there is MAG, that is magnetometer, which measures the magnetic fields at L1 and provides 60-minute early warning before the coronal mass ejection it hits the region, or it hits the earth. So ultimately right now, from seeking the data from the other countries, now India has moved ahead, and now we are one of the nation which is providing and collaborating with the data related to the coronal mass ejection and the solar wind that is emanating from the sun's surface. Over here, you must be seeing that, okay, this has not happened so far. So what will happen? So let me tell you that there were the previous incidents as well. All right. In 1859, there was the Carrington event that was very massive. In the Carrington event, what has happened was that this is the most powerful recording geomagnetic storm where the telegraph systems, they sparked. Ultimately, they shocked the operators and setting the offices on fire as well. There had been auroras which were visible in Hawaii and even in Bombay. You can just imagine that the auroras, they were visible from Bombay as well from India, that is Mumbai. Then in 1989, there was Quebec blackout where the solar storm, it collapsed the hydro-Quebec power grid in just 9 seconds. And the people, they were without power for 9 hours. 6 million people, they have lost power for the 9 hours total. Then in 2022 as well, there was a Starlink disaster where a minor geomagnetic storm, it increased the atmospheric drag. And ultimately, 40 of the 49 newly launched Starlink satellites, they failed to reach the orbit that costed the SpaceX more than $50 million. So this is not something that is to be taken, lightly. It is a massive event that has shown in the 1859 itself. And if this class of the storm, it will happen today. So there will be the catastrophic effect that you will see in the failure of the navigation satellites, the GPS, the internet, the power grids, and the estimated cost will be in trillions and trillions of dollars. And the technology advances, we must know that fragility also increases as well. Now, when it comes to the different storms, so there are the key, indexes or the scales which had been used by NOAA. There is G scale or geomagnetic scale that is for the geomagnetic storms. And over here, we have the different G scales from G1 to G5, where G1 is the minor and we have G5 that is the extreme that is there. And when it comes to G3, so right now, this storm is G3, that is one of the strong storms that will be there. Now, the R scale is for the radio blackouts. Over here, you can see, when it comes to R scale, we have R1 to R5. Again, R1 is the minor and R5 is the extreme. And in June 2026, the scale was R3, that it was strong. Then comes the S scale, that is for the radiation scale, or it is basically for the proton scale. And over here you can see in the S scale we have S1 to S5 again, where S1 is minor and S5 is basically extreme. And this is basically for the hazard, that is for the astronauts and even for the polar satellites or the polar flights which are there. So that is all in today's session. I hope you have a complete understanding of the what geomagnetic storms are and how they are formed, and also why it is important that now we have the geomagnetic storms which are becoming frequently, they are frequenting the earth in very less duration of time, and the intensity is also rising, and that is because of the solar maxima that the sunspots they are attaining right now in 2026. Alright, so that would be all in this video, but at the same time, if you are preparing for the UPSC 2026, 27 or 28 or even for 29, you can enroll into the courses which are available for on the platform of StudyIQ platform. Alright, what you can do is that you can enroll into the courses which are based upon the structured smart model, and ultimately you can enroll into the courses, and for the maximum discount you can use the code that is BRS Live, and you can enroll into the batches. So that would be all in today's session. Thank you very much guys for joining me over here on the platform of StudyIQ. I will see you in the next. So till then, take care of yourself and bye-bye and Jai Hind.